Hello, geometry students. Thank you for taking your notes today. Put your name, date, and period. This is lesson 4-5, Congruence in right triangles. Students will be able to prove the hypotenuse leg theorem, and use congruence criteria for triangles to solve problems and prove relationships in geometric figures. Go ahead and read your vocabulary out loud right now. You can read it in English or Spanish. Ready? Let's do it as a class, or you can do it silently since you're working on these notes alone today. Okay, let's practice some of our vocabulary. You're going to draw an arrow from each term to point to where it is located on the diagram. Pause the video right now while you do this. Here you can check your work to see if your arrows are going to the correct places on this right triangle. For the critique and explain problem, I'd like you to read both about Seth and Jay and look at the diagram. When you finish looking at the diagram and reading both of their explanations, answer this question. Do you think either student is correct? Explain. So after you finish reading the questions, you can talk to a partner and then you can fill out these notes. I'm not going to give you the answers, so pause the video and write down what you think. At the top of your page, I want you to write down the name of this theorem, and it's the hypotenuse leg theorem. If the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. And the reason this is true is because if you remember the Pythagorean theorem, if we have two sides, a hypotenuse and a leg, or two legs of a triangle, we can find the third side. And if we did that for these two triangles, we would find that the third side is congruent. So then we would have side, side, side. So from that, we can now say always that these two triangles are congruent by hypotenuse leg because they're right triangles and we have a hypotenuse and a leg that are in common for both. So triangles MNL and PQR are congruent. And go ahead and read this example to yourself, or you can read it with a partner. Have any of you ever been on a ladder before? Can you tell like how tall a ladder can go? When you're climbing a ladder this tall, you can't just put it straight up against the house. You have to put it a little bit away from the house. And so he's washing the windows, and the ladder is 10 feet tall, but it doesn't go that high on the side of the house because it's pushed out away. So the hypotenuse is 10 feet, but the height of the triangle is actually less than the hypotenuse. And we know that because in a right triangle, hypotenuse is always the longest leg. So if the ladder for this first window, and we can label this triangle ABC, let me get a lighter color, A, and then put C up here, maybe, and B right here. That's not really showing up. I think I need red. Pink C, ABC. Then we would want the same triangle over on this window. So that triangle would have the same height, and it would go out as far as the rose bush. And those two triangles would be congruent because we want the height to be the same. So this height should be the same as this height. And this hypotenuse should be the same. And then this leg should be the same. So if we labeled this triangle D, E, F, we would want those two triangles to be the same. And so this length out here should go to the same length as the rose bush. Okay? So the same length from the house to the rose bush. That's how far you want to put the ladder away from the house. We have this try it over here. And it's asking what information is needed in order to apply the hypotenuse leg theorem. So the hypotenuse leg theorem on triangle LMN, we're given the hypotenuse. And on triangle PQR, we're given a leg. So what else would we need to know? Well, we would need to know if M and N is also 5, like Q and R. So we would need to know if M and N are congruent to Q and R. So that's a question mark. Are they congruent? And we would also need to know the hypotenuse of the other triangle. So we're given the hypotenuse LN. Is that congruent to the other hypotenuse? Remember, the right angle points to the hypotenuse. So is LN congruent to PR? And if we knew that, then we would be able to use the hypotenuse leg theorem. On this next example, we're going to be writing a proof. This proof is going to have 12 steps. And we want to show that this triangle is an isosceles triangle. They are giving us that FD is perpendicular to AB. So I'm going to highlight that on here just for you to see it, but you don't have to highlight it because you're going to end up getting too many things highlighted. So after I highlight it, I will erase it. FD is perpendicular to AD, and then FE is perpendicular to FE is perpendicular to AC. I'm wondering if they left off C right here. I think so. And I also made a mistake. It's actually AB. So that whole thing. Okay. So let's just put in here AC, the letter C. So we have that in our diagram. I think maybe I cut that off when I was cutting and pasting. All right. From here, we're going to just start with that information. So we're going to write that FD is perpendicular to AB and FE is perpendicular to AC, and that is given. From that information, we can say that some of the angles are equal in measure, and the reason we can say that they're equal to 90 degrees is by the definition of perpendicular. So the definition of perpendicular, and if you didn't know that that symbol means perpendicular, then you should also write the word perpendicular so that you can get used to that being the symbol. So what's perpendicular? Well, or which ones are equal to 90 degrees. So the angle AEF, I'm going to just clear this highlighter so that you can see, oops, what angles I'm talking about. So I have this angle AEF right here, and I have the angle ADF as well. Those two angles are congruent. And the reason why is because they're right angles. So they're congruent and they equal 90 degrees. In addition, I hope you left space, we can also say that these angles here are 90 degrees and that they are congruent because they are perpendicular to the other lines that we just found. And they're a straight line, so if one of the angles is 90 degrees, then the other angle has to be 90 degrees as well, so that they add up to 180, being a straight line. So then we'll say angle FEC is congruent to angle BDF, or FDB, I should say, FDB, because those are equal to 90 degrees as well. So they are congruent. And they're corresponding, right? They're in the same spot. Okay, I'm going to erase that now because we have that. And we're going to move on to the next part. We have 1, 2, 3, 4 triangles. All of those triangles are right triangles. And that's going to help us with some more information. So their definition of right triangles. And so what triangles are they? Well, we have triangle AEF, triangle ADF, oops, not and, because we have 4 of them, triangle FBD, and triangle FEC are right triangles. Oops. Running out of space. Okay, I wanted to fit this onto your note paper, and because of that, I did not give you very much room to write, so write small. Number 4, we're going to have a given. I know we normally start with what's given, but because this is such a long proof, we're starting with given things in different spots. So for number 4, the other thing that was given to us is that AE is congruent. That's side AE is congruent to side AD. And that was given to us. And why is that important? Well, let's highlight that on our triangle. AE is congruent to AD. They gave us that. We're trying to prove that the whole triangle is an isosceles. Isosceles means, like, remember that's what we're trying to prove? Prove that the triangle is isosceles. And if we can prove that those two sides are equal, then we can start proving more things about the whole triangle. The next part of the proof that we're going to say is that AF is congruent to AF, and that is by the reflexive property of congruence. Okay, and that is talking about this line right here. Okay, and this is going to help us get to the final thing where we are trying to show that we have an isosceles triangle. The next thing that we're going to prove is that these two bigger right triangles are congruent. So AEF, triangle AEF, is congruent to triangle, let me see, ADF. I want to get the order correct. And the reason for that is because they're both right triangles and we have a hypotenuse and a leg. This shared side is the hypotenuse. So hypotenuse leg theorem. All right, if we can prove that those two triangles are congruent, so I'm just going to highlight the two triangles. This triangle is congruent to this triangle. If that is true, then we can also say that EF is congruent to DF. So the side EF, which is right here, is congruent to the side DF. And the reason why is because if those two triangles are congruent, then every part of the triangle is congruent. So corresponding parts of congruent triangles are congruent. Erase that. And we're going to go to something else that was given to us. Okay? So let's just look at what we've been given so far. We've already dealt with the perpendicular. We've already dealt with these two sides. So what's left is we have FC is congruent to FB. And that was given to us. And we can see that in our triangle right here. FC is congruent to FB. From this given statement, we can prove that triangle FDB and triangle FEC are congruent because of the hypotenuse leg theorem. Right? Because we were given, I'm going to highlight what we were given. We were given this FC and FB are congruent. We also just found out in the step before that these are congruent. And we also found out before that the angles are 90. And if that's true, then those two triangles are congruent because of the hypotenuse leg theorem. If that's true, then we can prove something about their angles. And in an isosceles triangle, we have congruent angles at the base. So we can prove that angle C is congruent to angle B. I'll highlight that for you so you can see it right here. Those angles are congruent because the triangles are congruent and corresponding parts of congruent triangles are congruent. For step 11, we have side AC is congruent to side AB by the converse. So we're saying that this whole length is congruent. The converse of the isosceles triangle theorem. So therefore, the whole triangle ABC is isosceles. By the definition of isosceles triangle. All right, nice job on your notes. Today I would like you to turn in your notes since there is a sub.